Okay, we learn about some of the concept related with the general purpose cache-based microprocessor architecture. Now, uh, we continue with that concept. So, cache-based microprocessor is nothing but a we learn about that one. Okay, so because of some limitation of Zoom, so we re again started with that. So cache based memory is nothing but a small size, high speed type of volatile computer memory that provides a high speed data accessing to a processor and store frequently used computer program, application and data. So it is a small size, high speed type of volatile memory, right? So just look out. Suppose we taking one example. We have executed some data. In data, we make a two type. One is related with a integer type, and second is related with a float type. So we say that it is an integer and float type. So what we'll done, the main memory, uh, which is interfaces with a processor, number of processor. In that, the first cache cache memory, that is a cache base, which will be a help. It is a volatile memory which can access the data from this memory. It help to access the data related with a to getting a fast data for the processing to execute the instruction fastly. So that concept will be clear here. Um, so next, when we go with the L1 and L1 having a two parameter, one which can be access the data, right? And second is related with a instruction. So the requirement of data. So, suppose the A is equal to 2, B is equal to 5. So whatever the data which can be accessed by this one and what to be executed, either the addition, multiplication, division, whatever the operation, it is separately cached by that instruction cache. So instruction are separately cached and data are separately cached. So what will be? They getting fastly, simultaneously. Not before that, what will be happen? First, what we go with the data, collecting data, then we collect the instruction. Rather than here, both work will be done simultaneously. So execution of that process will be a work simultaneously. So instruction also ca- getting and the data also getting. So processes will be do the both operations simultaneously. So the time delay will be reduces execution. Next, there are two type of data. We say that integer and float type. So we make separate integer type of queue and floating type of queue. Separately, we make this by this instruction. And whatever the queue will be created, it is available here, memory queue. What instruction first executed, either the integer data will be executed or the floating. So it make a queue. So thus it is apply for floating point register file. So floating data will be a store here and integer type of data will be a store here separately. Separately. And both work simultaneously. Just look out, these are work are simultaneously. So addition of floating will be a do here simultaneously. Integer operation also done here simultaneously. Shifting of data also here done simultaneously. Floating point multiplication also done simultaneously. So number of instruction are executed simultaneously. So that will be a difference between a single your architecture of CPU, working of CPU with a cache-based microprocessor. So what will be a cache-based microprocessor will only help to get the data fastly and executed simultaneously. So operation of execution will be done simultaneously. So in integer data also do simultaneously and floating data also do the simultaneously. So result will be getting as early as possible. But before that, when we go with a serial port communication, so what we do, first we access the memory, then we collect the data, then we go to instruction. In instruction, if it is the integer, first go with integer, then we go with the floating, and then making the combination of integer and floating operation, and then produce the output. But with the help of cache based memory, we can do all the operations simultaneously. So that will be help to work more fastly, which will be help to more fastly. So we say that cache memory is a small size, high speed type of volatile computer memory that provides high speed data to access to a processor and store the frequently used in a computer program for the application and data. Is it clear? General purpose cache based process microprocessor architecture. Is it clear to everyone? So what is the concept related with the cache base? I think so it will be a clear. So first we understand the concept related with the, what is the single processor will be a do and what will be a next processor will be a do. Right? So this is a general purpose cache based microprocessor concept. Right? So regarding this parameter, we go with a general processor cache based memory. Right? Next, the concept is clearing that the cache memory is typically organized into a multiple levels such as, just I move here, L1, L2 and sometimes L3, with each level offering a progressive larger but slower storage, or whatever the concept of that will be a storage. The arithmetic unit for the floating point and the integer for integer operation. The register hold the operands to be assessed by the instruction. So load, that is the LD, and store is the ST, storing the data. Unit handle the instruction that transfer the data and from a register. Right? ST is for the use for the storage and LD is used for the storage. Here the ST and LD concept. Right? So cache holds the data and instruction to be a use. Right? So this is a concept related with a general purpose cache based microprocessor architecture. So it is a very important question, exam point of view. They ask most of the time. So second point is a implicit parallelism. So we go with the parallelism, right? Parallel computing is nothing but we go with the number of instruction which executed parallelly with the number of processor. So what is the implicit parallelism? That concept will be a know to understand. So for understanding that concept, we know to the parameter. Just look out. I make some highlights so it is easier to understand. Right. So going with that. So implicit parallelism is a defined as parallelism. It is a parallelism technique where parallelism is automatically exploited by the compiler or interpreter. Just concentrate out the word. That is the important parameter. The implicit parallelism is automatically exploited by the compiler or interpreter. The objective of implicit parallelism is parallel execution of code in the running runtime environment. What is the meaning of? Can anyone explain? The parallel execution of code in the runtime environment. Now we're doing number of program. We're doing the large program which have a number of models. Model 1, model 2, model 3, model 4, model 5, model 6. We make the combination of model by calling second model into one, third model into second. Is like that we call as per our need. But when the program will be a properly produced output, when all the model will be executed simultaneously as per their instruction at the time of runtime. So the implicit parallelism helps to execute all the code in the runtime environment. In the runtime environment, that is a very important parameter. runtime environment. So the compiler assigns the resources to target the machine for a performing parallel operation, to execute the parallel operation. Suppose we say that we require uh, addition of one number. Second instruction we require logical operation. Third require suppose some other operation, boolean operation, suppose true and false. But the result is showing that all three will be produce some single output. So that time the arithmetic, the logical, and the boolean operation need to be executed simultaneously. So if they are work simultaneously, they produce a single output. Same like that, number of application. One application is suppose you running as a gaming in your mobile. Second application you browsing. Third application you using YouTube. So three operation will be a work simultaneously. So whatever you require, the processing of three program simultaneously possible at a time of running, and it is done with a implicit parallelism. So implicit parallelism help to execute the whatever the instruction automatically in a runtime environment. So it clear that the parallel execution of code in the runtime environment. So they give the instruction to the machine perform parallel operation. The implicit parallelism require less programming effort and has application in share memory multi-processing, which have a capability to share memory multi-processing. So which can execute the multiple program at a same time. Is it clear? What is the implicit parallelism to everyone? Is it clear? So implicit parallelism will require
Yes, sir.
to execute the number of tasks at a same time at the time of environment. So it is a very important point. Runtime environment. Runtime at a environment. Just I go with second slide. So the example of implicit parallelism, how the example will be in exam point of view. This also question important. They ask about what is the implicit parallelism. Explain with one example. Explain with a one example. So there are n number of example of implicit parallelism. So first example is a pipelining concept. So pipelining is a very important parameter. So pipeline is an example of implicit parallelism that is being used by the processor to execute multiple instructions simultaneously. We have to execute multiple instructions simultaneously. That is nothing but a implicit parallelism. In processing of pipelining, each stage of execution is performed in parallel with the other instruction. That is very important. Execution is performed in parallel with other instruction. Means there are multiple instructions. Whatever currently you do, we also do other instruction at the same time. So there are number of type of parallelism. Suppose we take type of pipeline, the arithmetic pipeline and the instruction pipeline. We take arithmetic operation with some of the instruction. So we execute. Just look out this diagram. I make a small that one. Just look out this diagram. Pipeline versus a sequential processing. Pipeline versus a sequential processing. That concept. Just look out here. Pipeline. Hmm? Here is a I written as a pipeline, and here I written as a instruction. So just look out a sequential processing concept, right? So instruction 1, instruction 2, instruction 3, I1, I2, I3, right? Just look out here for I1, I2, I3. Just look out here also. Here I1, I2, I3. Here I1, I2, I3. Three instruction with some of the operation, with some of the instruction. F1 is a different data processing, D1 is a different one, and E1 is a different one. Same like F2, D2, E2, F3, D3, E3. Just look out for a first instruction, whatever we given, it is not only related with F1 also. It is related with F1. Just look out here F2, E2, and it is again processor. So how it will be executed? Just concentrate on here. The arithmetic pipeline are used for the sorry floating point operation, multiplication of fixed point number. What we say that the arithmetic pipeline are used for the floating point operation, multiplication of fixed point number. Example, x is equal to a into 2 raised to a. Just we take one example, a into 2 raised to a. So instruction pipeline, a stream of instruction can be executed by a overlapping fetch, decode and executed phase of a instruction cycle. This type of technique is used to be increase the throughput of a computer system. How they increase the throughput? We consider here. So just taking one example, we consider a sequential execution of three instructions. Instruction 1, instruction 2, instruction 3, each having three stages of execution, each having three stages. F1, D1, E1 is like F2, D2, E2, F3, D3, E3, right? Each having a three stages of execution. The sequence got is to be a following instruction side. Is like that. If each require 1 unit time and unit for each action, then the total time required would be a 9 unit. Just look out. Suppose we say that F1 require 1 minute, D1 require 1 minute, E1 require 1 minute. Same like F2, D2, E2 require 1 minute respectively. F3, D3, E3 require 1 minute respectively. So we require 9 minutes to execute this nine operation, right? We require nine operation. But in case of pipeline, execution of same instruction set of sequence would be require only 5 units. How it is? Just look out. So for I1, F1 will be executed same time, D1 will be executed same time, E1 will be executed same time, E2 will be executed same time, and E3 will be executed same time. So what we require? The five operation will be executed in a 1 unit. In a 1 unit. My meaning of that, the multiple instruction will be a work simultaneously with multiple operation. This is a implicit parallelism. In a I1, I2, I3, all instruction are working at the same time. So F2 will be required for this one. So they executed here in a I1 also. Just look out, F2 is related with the I2, but it need executed in I2. I1 when we executed, same time I2 also be executed, same time I3 also be executed. Same time I3 also be executed. So whatever the operation of, suppose these will be a do the arithmetic operation. Suppose we say the addition, this will be a do the multiplication, this will be a do the division. So all three will be a work the same time. So requirement of time will be a very less to execute the number of operation, and this is possible with only implicit parallelism. So because of that, it is a very important, and this is one of the best example for the implicit parallelism. Is it clear to everyone? Is it clear? Anyone? So we
Yes, sir.
go, yes. So this is called as a implicit parallelism, one of the example of implicit parallelism. Next example is a multi-threading for the implicit parallelism. What is a multi-threading concept? So multi-threading is defined as the process of executing the multiple threads in a single process. I will explain that one. Every process has its own instruction and can be executed independently of the other threads. So that will be a second point we use in a multi-threading concept. So what will be happen in multi-threading? Uh, so number of threading is like that arithmetic concept we taking one arithmetic. Just I explain with some diagram so you can understand. Suppose a arithmetic unit is like that. First will be do the addition, second will be do the multiplication, and third will be do the division. So multi-threading defines as the process of executing multiple thread. So thread one in suppose this addition which having a addition of 10 numbers and this having a addition of suppose 10 numbers. This also addition of 10 numbers. Right? Suppose we say that each having a addition of two numbers in between here. In between that, suppose A plus B, then C plus D plus E. Third addition, suppose A plus F plus H. And fourth addition of 3 is like that. We have multiple addition. So a single arithmetic which have an addition which is divided into a number of threads. So this is the first thread, this is the second thread, this is the fourth thread, this is the again whatever we use a seventh thread, eighth thread, ninth thread. So small addition also divided into a small task or small task is called as a small thread and are work simultaneously. Are work simultaneously. So that will be a comes in a multi-threading concept. Small task is divided into again sub-task, right? Here the addition one task, right? This addition task also divided into a different addition, right? So we say that each addition is a one thread. Each addition is a one thread. Is like when we do the multiple threading. Same like for the suppose multiplication. So there are n number of multiplication. So these are also divided into sub multiplication. Then division, also subdivision. This subdivision of single task, arithmetic addition is a one which divided into some different addition, that is a threading. So this also called as a pipeline or a implicit plagiarism. Sorry, concept. Then vectorization is one of the another concept. So vectorization technique used for the optimizing the code in order to execute it on the process that support the single instruction and multiple data instruction. Means a vectorization process which capable to execute multiple data instructions. It allows the performing the same operation on a multiple data element at the same time. What we say that it allows the performing the same operation on a multiple data elements on the same time, right? Suppose a same data A is equal to and B is equal to C, which will be used for addition also, which will be used as for division also, which will be used for the multiplication also. So all three will be used simultaneously by a vectorization, right? So implicit parallelism program language, there are number of programming language used for the implicit parallelism, either Axiom, BMDFM, that is binary modulator data flow mechanism, HPF, that is high performance Fortran, and IDC, that is a ID is related with the invariant data flow and LabVIEW. So that is concept related with the implicit. That concept we explain with the example. So two example will be needed. I just cleared that one. and we explain vectorization and multi-threading by one example, right? So again, I make a recording that one, and again sharing the link related that. In that we explain the multi-threading concept and vectorization concept, right? So just